Today we'll complete lesson 6 by looking at 6 different questions that utilizes the 180 rule, 180 degrees rule, the Pythagorean theorem, and one of the trig ratios. So we'll be referring to these 3 concepts throughout these questions. So each question may use a combination of these or just one of them. So we'll refer to them. So there are 6 questions I'll look at, and they all will apply using one of these 3 rules. Just to review, the angle of depression. So the angle of depression is the angle, if the angle goes upward, it's called an angle of elevation. If it goes downwards, angle of depression. And it's always from the observer's horizontal line of vision. So if a person is standing up here, as this example, as this diagram shows, then the angle of elevation is from your viewpoint, horizontal viewpoint, going up, elevation, angle of depression going down. Generally speaking, the angle of elevation is generally measuring from the ground up. I'll show you examples where in different situations it may apply differently. Also, the angle of inclination we mentioned is from the value of the x to any line. And it's essentially the same as the angle of elevation. So just remember these 2 terms, angle of elevation and angle of depression. None of these questions have anything with the angle of inclination. But if you come across any questions regarding angle of inclination, you're referring to angle of elevation. So let's look at the first question. So the first question tells you, and they ask you to solve each of the following questions. And when rounding is needed, express side lengths or distances to the nearest hundredths and express angles to the nearest degree. So I'll round, even though it's set to the nearest degree, I'll continue to round to the nearest 2 decimal places or hundredths. So look at question 1. It said the angle of elevation of the sun is 68. When the angle of elevation of the sun is 68 degrees, a tree casts a shadow on the ground that is 14.3 meters long. How tall is the tree? So whenever we have these questions, we try to make an illustration to help us to understand the problem. So let's say this is the sun. We'll go here, the sun, call this the sun. And here we have the ground. So we have a tree, and so here we have a tree somewhere, we'll refer to it here. And the sun is shining, and let's say it casts a shadow. So when the angle of elevation of the sun, so the angle of elevation, so now this, you are looking from this vantage point here. It's your eye here. So this is referred to your angle of elevation from the ground. So this is the ground here. And the angle of elevation is 68 degrees. Now, tell you a tree casts a shadow on the ground that is 14.3 meters long. So this is the ground. So the shadow is on this ground here. So it's all there's a shadow. From here onwards, it's all sunshine. This is my tree, top of the tree here. So they tell me that the shadow is 14.3 meters. So I'll put 14.3 m. The question is, how tall is this tree? So we want to find the height. So remember, whenever we have any of these questions, we label the sides. Now, by the way, we can input our angle here. That tells me it's 90 degrees because the tree is perpendicular, assuming the tree is straight. So we label the sides of the triangle. Now we have the angle here, so this will be the opposite side. The ground will be the adjacent side. So given adjacent, which is 14.3 meters, and the angle theta, 60 degrees, we asked to find the opposite side. Now, in all of these questions, we have to refer to one of our trig ratios. So I go to my trig ratios here. So keep it handy here. And I look for a match for adjacent and opposite. So it wouldn't be sine, it wouldn't be cosine, it will be tangent. So I'll use a tangent trig ratio. So I'll have there tangent theta is opposite over the adjacent. Then I substitute the values given from the question into my trig ratio. So I have tan 68 degrees is equal to the opposite, which I don't know. I can put x in there, but for now I'll put opposite. And the adjacent is 14.3. So doing the algebra here, the opposite now will be equal to 14.3 tan 68. So I get my little calculator out, and I'm going to do some magic with it. Well, let it do some magic, not me doing the magic. So we have 14.3. So we have 14.3 tan 68. And that gives me a measurement of 35.39 meters. So the height of the tree is 35.39 meters. Okay, so let's go on to question 2. And this question referred to a kite. And it's obviously flying in this question here. But the string of the kite is 350 meters long. Now the angle the string makes with the ground is 50 degrees. How far from the person holding the string is the person standing directly under the kite? So we have two people. One is directly under the kite. One is holding the string that's attached to the kite. And they tell you the string from the person holding the kite to the kite is 350 meters long. So let's put all that into a nice triangle. So here's our kite. Right. So the kite, the string of the kite to the person holding it here. So we call this person, this is our ground. So we have our ground here. And if we have person 1. So the string of the kite set us is what? This is my string I'll put here. 350 meters. Now, tell us the angle. Now, this is the person here. This is your wonderful eye. So the angle the string makes with the ground is 50 degrees. So this angle here is 50 degrees. Now, how far the person holding the string is the person standing directly under the kite? So the person 2 here is directly under the kite. So we may have a 90 degrees there. The question is, how far is that person, these persons are from each other? So let's label our triangle now. We have a right angle triangle. So this will be the hypotenuse. This will be the adjacent because that's our angle. Adjacent. So we asked to find the adjacent. So we write down what's given. We given the hypotenuse, which is 350 meters. We given a theta, 50 degrees, and we asked to find the adjacent side. So we refer to our trig ratio again, and we find where we find a match would be hypotenuse and adjacent will be cosine. So we are going to go to our cosine rule. So we can apply the cosine. So adjacent and hypotenuse. So apply that. We have cosine theta is adjacent over the hypotenuse. So we have cosine 50 degrees. We don't know what the adjacent is, and we know the hypotenuse is 350. So the adjacent is equal to 350 cos 50 degrees. And bring up my good old calculator here. So 350 cos 50 gives me a measurement of 224.98. Somewhere around adjacent. Oops. 224.98 meters. So we can conclude that the person, the two individuals here, are 224 meters apart. The two people are 224.98 meters apart. So step 1, we construct a diagram of the problem. And since we are working with right angle triangle, we label the sides based on what's given. And normally you'll label the side based on the reference angle given. Okay. Let's go on to question 3. And this is a typical question you would get where a 9-foot ladder leans against the side of a wall, and the bottom of the ladder is 1.5 meters from the base of the wall. Find a measure of the angle between the ladder and the ground. So whenever you're asked to find the angle, you will use your inverse button or your second button. What I mean by that, in this case here, I'll use the second button to find my angle. So I'll show you that. So let's make an illustration of the question. So a 9-foot ladder. So here we have a wall. So the wall is perpendicular to the ground. So we have a ladder that's 9 feet long. Oops. So here's a ladder, 9 feet. Now the bottom of the ladder, which is here, is 1.5 feet from the base of the wall. Well, I'm not drawing this. This is not drawn to scale. So actually, let's redo this. Looks kind of really odd. So this is my wall. This is my ladder. And the ladder is 9 feet. And the bottom of the ladder is 1.5 feet. That's some more realistic look. Find and measure the angle between the ladder and the ground. So we need to find this angle here. So using the angle that's being requested, we will label the size of a triangle. So this is my angle. This will be my adjacent side then. And this will be a hypotenuse. So given we're given the hypotenuse, which is 9, the adjacent, which is 1.5. And we asked to find theta. So in this case, we have a hypotenuse and adjacent, that will give us cosine ratio. So these are cos ratios. Cos theta is equal to the adjacent over hypotenuse. So we don't know what, we need to find our angle, which is adjacent is 1.5 over 9. So now we'll use our calculator. So this will give us, so the second button, or in yours might be inverse button, cos, so go to my calculator here. So second cos 1.5 divided by 9, close bracket, enter, and that gives me an angle of 80.41 degrees. So the angle the ladder makes with the ground is 80.41 degrees. Look at question 4, and then look at 2 more questions. Question 5 in the booklet is similar to question number 2, so I wouldn't go over that question. So a theme park has a very long slide. The slide covers a horizontal distance of 1,200 meters and a vertical distance of 213 meters. How many meters long is the slide? So we're looking at the slide here. So this is our ground. So put this illustration here, our ground. And there's this very long slide going up. Now the slide covers, so the ground horizontal distance. So this is our horizontal distance, which is 1,200 meters. And the vertical distance is 213 meters. The question asks, what is the length of the slide? Now, in this case, they're asking you to find the per side. So since they're asking you just to find the side when given two sides, we then apply the Pythagorean theorem. Okay. So we're given, so we can label these, if you so these are, we can label this as side A, side B, and this will be side C. So we have A is equal to 213, B is equal to 1,200, and we have to find C. So we know formula C squared is equal to A squared plus B squared. So C squared is equal to A was 213 squared plus 1,200 squared. Now, you'll need a calculator for this because it's a lot of huge numbers. When I have these huge numbers, I simply put them into the calculator and let the calculator do its work. So we have C squared. Now, 213 squared, if you were to do that, so we have 213 squared. So remember, hit that square button. This gives me 45,369 plus, we have 1,200 squared. Gives me 1,440,000. If I combine those two, let's just put 213 squared. I'll get a huge number, which is, so C squared is equal to 148,539. So C is equal to the square root of that. So C, I'm going to hit my square root button and the answer, which is equal to 1,218.76 meters. Okay, they ask you to find the angle of inclination. So the angle of inclination would be this angle here because you're looking at from the ground. So remember the still angle of inclination, and our angle of inclination, we always looking from the ground up or from the x-axis going up. So let's label this triangle based on reference angle, or the angle being asked. So this would be the opposite side in this case. And what's also given, this is adjacent. So I'll use what's given. I could also use the hypotenuse because I determined it already. But I'm going to use what's given. And the numbers are they're whole numbers, so easier to work with. So here we have our 1,200 and 213. So we have opposite and adjacent, and go back to our reference triangle. Opposite and adjacent is tangent. So we'll use a tan ratio. So we have tan theta is opposite over adjacent. So tan Our opposite is 213. Our adjacent is 1200. So this, to find my angle at second, 10, 213 into my calculator, divided by 1200 equals, so go to my calculator here. Second, 10, 213 divided by 1200. This gives me a measurement of 10.07 degrees. So 10.07 degrees. So the angle of inclination (10.7 degrees). Okay, we'll go on to question 6. We'll skip question 5. This is a little bit tricky one. And in question number 6, we have a submarine, and we have to find the depth underwater. What is the depth underwater is a submarine? So, but here we have a ship is on the surface of the water. Let's see if this is the surface of the water. And we have a ship up here. See, they have a nice flag there. So the ship here. Now, so the ship is on it, and its radar detects a submarine at a distance of 238 feet. So our submarine is below the water here. So the distance from the submarine to the ship. So we have our ship here, and we have our submarine here. So the distance here is 238 feet. But they also tell us the angle of depression. So the angle of depression is like you're looking from here, your point of view. So the angle of depression is this angle here. So you're going down from the horizontal. So the top of the water, let's give me 23 degrees. They ask us to find how deep, how far down below the surface of the submarine. In other words, what is the depth here? So we're given 23 degrees. So now let's label our triangle based on what's given. This is my angle, or the angle given, so this will be the opposite side. This will be my hypotenuse. So you ask to find the opposite side. So given theta, hypotenuse, which is 238 feet, I'm asked to find opposite. And this I'll go to my trig features again and find when there's a match between hypotenuse and opposite. So hypotenuse opposite to give me the sine. So I'll use a sine trig ratio. So I have a sine theta is equal to opposite. So sine 23 degrees. Opposite, I don't know. My hypotenuse 238. So my opposite then is equal to 238 sine 23. Go to my calculator. So 238 sine 3 gives me a depth of 92.99 feet. So this is the depth of the submarine. Okay, the final question, 7, has to do with the tower. So an observer is 120 feet from the base of a TV tower, which is 150 feet tall. Find the angle of elevation to the top of the tower from the point where the observer is standing. So let's illustrate this. This little graph. And so, and here's a TV tower. So it's 50 feet from the base of the tower. So here's the base of the tower here. And the person who's here. So they are 120 feet. So now they want to find the angle of elevation. So here's the person looking here. This is the top of the tower. So now they want to find the angle of elevation here. So the angle so now we have our right angle triangle. Let's put a little 90 degrees there to indicate it's a right angle triangle. So based on our angle, reference angle here, this will be the opposite side. This will be my adjacent side. So what's given? The opposite and adjacent. So let's write down what's so given opposite, which is 150 meters, to adjacent, which is 120. So it's supposed to be feet. And you have as to find theta. We're missing. So based on our triangle, trig ratio, we know that over adjacent is matched, so that's give us tangent. So I'll put here tangent. Tangent theta is opposite over adjacent. So we have tan, or opposite is 150 over 120. So we have to use our second tan and 50 divided by 120 equals. So second 10, 150 divided by 120. That gives me an angle of elevation of 51. So angle of elevation And that's the final question in this section. The next lesson, we'll be looking at oblique triangles, applying the laws of sine and cosine.